This video is about debugging multi-threaded code. Due to the large size of this topic, we will limit ourselves and explore just a few key ideas. My name is Rick Lineker. So here's what this video covers. The first is how to prevent bugs in the first place. It's easier to prevent bugs than to actually fix them. The second thing we'll talk about is that the debugger can sometimes mask off bugs in a multi-threaded application. The third thing we'll talk about is the option of running code in a sequential way while you're trying to debug it. And lastly, we'll talk about using trace statements to track down problems. Okay, so now let's talk about preventing bugs in our multi-threaded code. So let's start with this premise. We don't want to write code that introduces bugs. We also want to try to write code that will be easier to debug should we have to do so. And lastly, we'll try to use well-known patterns, and right now we'll look at my top 4. So my bug prevention rule number 1, always use braces. Now, I teach computer science and software engineering, and when I suggest this to my classes, I get a lot of groans because people are not accustomed to always enforcing this rule. But I have become used to it because it has really saved me over the years. So let's take a look at this example. If condition, then the next line is indented, my function. Seems pretty obvious, right? But if we go to the next line, what it really should be, to avoid any ambiguity or questions, if condition, open curly, my function, close curly. And here again, if you don't want to line up your curlies, I won't nitpick with you there. However, I found it much easier and better for debugging if the curlies are lined up. Now, what does this avoid? Well, let's take a look at the next example. If condition, next line, my function, which is indented, and then the next line, your function, which is indented. Notice that at first glance, it's hard to tell which function is in response to the if statement and which one isn't. Okay, so if you use if condition open curly, my function close curly, followed by your function, there is absolutely no way you can misread that. Rule number 2, always use the const keyword whenever possible or practical. And what this does is to prevent other pieces of code from changing the contents of a variable once it has been set. This is good especially for variables that should not change once they've been initialized. And it's really good for parameters that are passed by value or as pointers. And as far as the pointers go, this happens to me and is most convenient when I'm using strings. And rarely, fields and structs that should not be changed. Bug prevention rule number 3, whenever possible, use static variables and functions. Now I know this goes against many programming paradigms, especially in the object-oriented world. But what I'm going to suggest is in the multi-threaded world, sometimes you have to do things in order to make sure you get the results you're looking for. So what does this do? This reduces module coupling. I might have a function over here running in thread number 1, and over here in thread number 2, I want to make sure that in module 1, that is completely private. That static means it stays within module 1. Anything marked static in module 2 will stay in module 2, and there will be no overlap. So this will prevent problems down the road. Now, it's not always a good idea. It's not always a good design pattern. But when it's possible and when it makes sense, consider doing it. So bug prevention rule number 4. Use the volatile keyword for variables that are accessed in multiple threads. So bug prevention rule number 4. Use the volatile keyword for variables that are accessed in multiple threads. Okay, here is why you want to do that. Because most of the time the compiler is going to try to provide optimizations so that your code runs faster and better. Some of those optimizations might include keeping the value of a variable in a register rather than continually read the value out of the memory location. Well, if thread number 1 changes the value in that variable, and thread number 2 thinks it hasn't changed and is just storing that value in a register, then it's going to have the incorrect value and your code may not work. This does not provide any kind of synchronization mechanisms. This doesn't mean you still don't sometimes need semaphores and mutexes and critical sections and so forth. Some bugs that happen in a multi-threaded application are difficult to detect when you are debugging. That is because many bugs are dependent on timing. And if the timing gets thrown off, these bugs might not surface. Well, what the debugger does is it slows things down. Or it might slow things down here and not here, especially if you've got a breakpoint set here. So I just want to warn you that many times when you run the debugger, a bug may not be evident. One of my strongest suggestions is to run your code as sequential code. It's possible that any bugs you are seeing or experiencing don't have anything to do with the multi-threading. It's possible that in a sequential environment, they would occur and be easier to debug. So if you run your code in a sequential environment and the bug still surfaces, then you can stop looking for multi-threaded code that is going awry. Here's an example. Let's say you're using OpenMP. Okay, and here I have Pragma OMP parallel 4. So this is a parallel 4, and within the 4 it's splitting up into multiple threads and it's doing its thing. Now there might be a bug there somewhere. So what I can do is change the Pragma so I tell it that the number of threads is 1, which means there's no multi-threading. It's just one thread that's running this for loop. If I do that and the bug surfaces, then I know it's a bug that has nothing to do with the multi-threading. If it doesn't surface, then I have a multi-threading issue. And this will really help you in tracking these bugs down. Trace statements are often the last thing I try when I'm debugging multi-threaded code. They shouldn't be. And the reason is because trace statements take a bit of extra effort. They should be one of the first things I try, but old habits die hard. From within a thread, you can use trace statements to output debug information to the console window. And this lets you do a postmortem, say, after a bug has occurred or after you've ended the application. So here's an example. Trace.write, and then you want to output the string data. And I normally will write some sort of function that serializes the object data to a string. Then once you've done that trace.write, you act upon the object, and you do another trace.write. And then by comparing the two trace.writes, you see if acting upon that object was correct and if everything went as you expected. Just taking a look at a small subset of this topic shows us how huge it can be and how complex things can get. But now you've gotten started, go from here and make your own discoveries.